Hello everyone. Sorry I wasn't able to be here to do this in person, but sometimes meetings are going to get in the way. So we're going to do this lesson over video, and we're going to finish up the chapter. Remember, you have a test tomorrow, and we're going to finish up the chapter by talking about tables and rules. And we're going to start making a big connection in algebra, which is connecting an algebraic expression or an equation to a table. And so the tables of values are going to become really important because we've spent the last few days talking about evaluating expressions where you can plug a value into an expression, and also we've spent a lot of time on writing expressions, equations, and inequalities. This is going to kind of bring a lot of that together, where we're going to take that idea of plugging in, the evaluating, and using that to expand what we're looking at. What we mean by that is you see here a table on the screen, and that table is representative of the rule, we say 4n minus 2. Now hopefully over the last few days you've picked up on the idea that 4n minus 2 means you're going to take whatever number is n, times it by 4, and subtract 2. And we could plug any number into that. And so what we've gone ahead and done here is we've made a table of some of the values that you would get if you plugged in to that rule. For example, if you plugged 3 in to that rule, you would get 10, because 4 times 3 is 12, minus 2 is 10. We then plugged 4 into that same rule. 4 times 4 is 16, minus 2 is 14. That's why we have 4 and 14 together. 5 would be 4 times 5 is 20, minus 2 is 18. And you can see that pattern continuing here, where every time, if you take the number in the top row, times it by 4 and minus 2, you get what's in the bottom row. So the top row represents our end values, or what we call our inputs. The bottom row represents our output values. That's what you get after you plug in to that expression. So we're going to use these tables and rules in multiple directions today. We're going to go forward with the tables and rules, and we're going to go backwards. So let's go ahead and get started. As you can see, I've given you an input-output table here. And we were asked to make an input-output table for the given rule. Our rule is over here. If the top column, or the top row, is represented by n, the bottom row is represented by 2n plus 1. So in other words, you're going to take whatever value is in that top column in the input row, and whatever is in that input row, you're going to plug into the rule 2n plus 1. For example, our first input is 0. We're going to take what's in the top row, plug it in to get our bottom row. If we take 2 times 0, you get 0, plus 1 is 1. Our second output is found by plugging 1 in for n. 1 times 2 is 2, plus 1 is 3. So what we're really doing here is we're just doing that evaluating expressions we did earlier in the chapter. We're just doing that repeatedly by continually plugging in a new value to the same rule, because we don't know what n is. We're just plugging in possible values for n. So if you plug in 2, 2 times 2 is 4, plus 1 is 5. If you plug in 3, 2 times 3 is 6, plus 1 is 7. If you plug in 4, 2 times 4 is 8, plus 1 is 9. So the biggest thing I want us to see here is our rule takes us from the input to the output. We don't look for a pattern going across. 0, 1, 2, 3, 4 is a pattern, but we're not using that pattern at all. It may not be a pattern in future problems. What you need to notice is we simply take the top number, our n value, and plug it in to n in the expression to get the bottom value. So the outputs come from the inputs. We go from the top to the bottom. We don't look at the pattern going across. The first example we did, where we were given a rule and we're asked to plug in, is generally more simple for most people. We're going to now look at 3 different examples where we go the other way. where we start with the table and we go backwards. We're given the table, we want to write the rule. So we know we input 0, got out -4. We input 1, we got out -3. So on and so on. We want to write a rule down here that represents n. So we're trying to write the rule that says, how do I go from the top to the bottom every single time? Most of you are going to be able to look at this and say 0 to -4, 1 to -3, 2 to -2. Every time I take the value on top, which is n, and subtract 4. A lot of you can do that very quickly and see that fairly easily. And so that's all we're doing when we're writing a rule, is we're trying to come up with, how did I go from the top to the bottom every single time? 4 minus 4, 3 minus 4, 2 minus 4, 1 minus 4. That's your basic example. That's what we would call a one-step example. You go 0 minus 4. Now we're going to look at a little bit more of a complex example where we're going to have two steps going on in the same problem. So as we look at this more advanced example, we have another input-output table where you're given all the values, but you're asked to write the rule. And so when you look at this, thinking back to the previous problem, we're able to do things like look at -2 to -1. How do I go from -2 to -1? Well, most people are going to say, I add 1. Well, let's see if that's the rule. Does 0 plus 1 give me 5? No, that doesn't work. So therefore, plus 1 is not my rule. If the rule's not as simple as just adding or subtracting, that tells us we're going to have a two-step rule. And for most of the things we're going to do, it's going to be multiply and then add or subtract. And because we're going to multiply or possibly divide, but more likely multiply this top number times something before we add or subtract, there's one really critical number. The number we're going to pay the most attention to here is going to be this special number right here. And that 0 is an extremely special number. And the reason 0 is so special is, if we're going to multiply n by something, it doesn't matter what I multiply by. If I multiply by 0, it's going to stay 0. So therefore, 0 is going to be my critical value. Because to go from 0 to 5, I have to add 5. So I know my rule right away is going to end in plus 5. I'm now going to have to come up with the rest of the rule. 0 is my key point for finding the addition or subtraction piece. If it doesn't work for all the rules, for all the steps, 3 plus 5 is not 14, so that does not work. We then need to think of the problem as working backwards. I'm going to do something to 3, then add 5 to get 14. An easy way to think about that is to work backwards. If I added 5 to begin with, I'm going to minus 5 and get 9 working backwards. If I do that same thing for each of these steps and I minus 5 from each of them, my numbers become more clear. Because when I say I took 3 and got 9, 5 and got 15, 8 and got 24, most of you are going to say that's times 3. 3 times 3 is 9, 5 times 3 is 15, 8 times 3 is 24. Then if I add 5, I get 29. 15 plus 5 is 20. 9 plus 5 is 14. So to write a two-step rule, I'm going to find my add 5 to begin with, and then I found times 3. So my rule turns into 3n plus 5. So that's my rule to go from my input to my output every time. So really quickly, we're just going to look at that again. What I did is I looked at 0, because 0 is my critical value, because anything times 0 is going to be 0. So to go from 0 to 5, I know my rule is going to end in plus 5. Then I need to come up with what step was done before I added 5. I multiplied 3 by something, then added 5 to get 14. The easiest way to work backwards is to say, if I know I added 5 at the end, I can subtract 5 from each value and try to figure out what did I multiply by. That's how you're going to come up with the rule. Those are very challenging for most people. They're not real easy. These will take some practice. So this is what you're going to do for the first half of your homework. Once you finish that, you can work on your review and make sure you have everything ready for your test tomorrow. Good luck. We'll see you tomorrow.